Okay, when we're doing applications with Sine Law, it's exactly the same as doing an application with SOHCAHTOA. We just don't have a right angle triangle, so we need to use a different property to solve the equation. So currently we have a situation where the tooth fairy is at Hannah's house. So we've got Hannah's house here. We know the tooth fairy is going to be looking at some other houses. So from the roof, he's looking at Rachel and Jessica's house. And he finds that we've got a 40-degree angle here. Okay, he knows that it is 300 meters from Rachel to Jessica's house, and that it's 250 meters from Hannah's to Rachel's. He's planning to fly from Hannah's to Rachel's and then to Jessica's. How much less would he just fly if he just did that? Okay, so what we have to do, and I'm going to do it on the next page, I just wanted to draw it out. It's always important to draw a good diagram. So here we had all of the information, and now we need to kind of solve it. So if we were looking at this, we've got our diagram was this, where we've got H, R, J, 300, 250, 40. And now we need to find out what R is. But to find R, we actually need to know angle R. To find angle R, the only thing we're given is this information and this. So we're going to need to find angle J. Then we can do 180 minus H and J to find R. And then we can use Sine Law again to find out side R. So when we start, we're going to be starting, we want to find angle J. So I'm going to do sine J over J equals sine H over H, because that's what I'm given. So then we're going to get sine J over 250 equals sine 40 over 300. We're going to rearrange. We're going to get J equals the sine inverse of 250 sine 40 all over 300. We're going to get J is going to be equal to, we'll call it 32 degrees. Now we can find angle R. Angle R is going to be 180 minus 40 minus 32, which is going to give us 108. And now using that information, and I'm just going to box it out here so it's a little easier to see, we can then find out what side R is. So we're going to have R over sine R. So again, this is now just the side version. And I'm going to use H over sine H because that's the given information from the question. It's always easier if you use that. So then we're going to get R equals H sine R over sine H. I just rearranged instead of substituting this time, but it's all the same. So we get 300 times sine of what's R, 108, divided by sine of 40, and we're going to get R equals 443.9 meters. Okay, well, we wanted to know how much quicker it would be or how much shorter it would be if I just did this. So then route difference is going to be 250 plus 300 minus what we found. So I'm taking this distance and I'm minusing away this distance. So minus 443.9. And for that, we're going to get 106.1. That's a 6. So therefore, it is 106.1 meters shorter to fly direct. Okay, we used Sine Law twice, we found the angles, and then we found the distance. Just a quick proof of the Sine Law. I know a lot of people struggle with visualizing this, and I've shown it that I've got all of the triangles here, so it can be any of these. All we're doing is making a right angle regardless of where we're looking, and then all of them work the same. I'm just going to show you the one that's with B and C, but all three of them work exactly the same. So if I just call that Y, what we're gonna do is I'm gonna use this right angle triangle on the left. We'll call this triangle 1 and this triangle 2. So on the left, if we wanted to solve with B, okay, we would have our hypotenuse is over here. Our opposite is over here. And adjacent is down here. Okay, we're not going to use the adjacent. We're going to use hypotenuse and opposite because that's sine. So then the sine of B would be equal to the opposite, which is y, divided by the hypotenuse, which is c. Now I'm going to just solve for y. All I'm going to do is say that c sine B is equal to y. Now so this is triangle 1. Triangle 1. In triangle 2, we're going to do the exact same thing. So in triangle 2, I'll do it in red. We've got our hypotenuse. We've got our opposite. And then we've got our adjacent. Again, we're going to use opposite and hypotenuse. So we would have sine C this time. It's equal to opposite over hypotenuse. Oh, it's not C, it's B. And then B sine C is equal to y. Well, I know that this y and this y are the same. So I can say that, let's call this, I guess, y2 from triangle 2. This is y1. But I know that y1 has to equal y2 because they're both that y value. They're both the middle y. So then from triangle 1, I would have C sine B equals, from triangle 2, B sine, C. Well, now all I'm going to do is rearrange this. So I'm going to take this B, and I'm going to divide it over. So I would have C sine B divided by B equals sine C. Now I would do the same thing with this C. I'm going to divide it over. Okay, so I'm going to just get rid of that and do it all in one step because I've run out of space here. But this C would divide over. So then we would get sine B over B equals sine C over C. And that's actually how you prove the sine law. We're just using that variable y that we've created two right angle triangles right in the middle, and we've solved for it. You could do it here with sine A and sine B, and here with sine A and sine C, and it's going to prove all of the different aspects of